it's Mrs. Pound, and I'm back with more from Chapter 5 on Newton's second law of motion, which involves force and acceleration. So, our objective today is to describe the effect of friction on a stationary and on a moving object. So, this is from section 5.4 in your book on friction. One thing we have to understand is what a fluid is, and this should be reviewed. Fluids are anything that flows, any liquid or gas. So liquids and gases are fluids because you can pour them, okay? You can pour a gas or a liquid. Air resistance is the friction acting on something moving through air. It is a form of fluid friction. So I want to get those few definitions out of the way because we're going to talk about them. So the first thing we need to know is that friction is caused by irregularities in two surfaces in contact with each other. And so I have a really cracked surface back here because in the background, because even smooth surfaces, something like a very smooth floor, even ice, if you were to magnify them, they would look like they have cracks and irregularities in them if you looked very, very closely and magnified them. And so that is what is catching. Now, friction, don't get me wrong, there are times we don't want friction because it causes heat, we lose energy to it and everything, but without friction, you would not be able to walk across the floor. It would be so slippery that you would just slide all over the place and you would not be able to stop. So friction actually is a very important force. We need to know that friction acts in the opposite direction with respect to the motion of a sliding object. So here with my box, I have the motion is to the right, friction is to the left. It always acts against the motion. So let's take a look at this example. A constant force of 50 newtons is needed to keep a box sliding across the floor at constant velocity because, remember, once we get something sliding, it should not stop unless an outside force acts on it. Well, friction is an outside force acting on things that make them stop. So if we want things to go at a constant velocity, this means there is a force of 50 newtons opposing the motion of the box. The net force on the box must be zero in order for it to move at constant velocity. Friction is opposing it at 50 newtons, so we have to push it at least 50 newtons to keep it, or at 50 newtons to keep it going at a constant velocity. If we pushed it with more than 50 newtons, it would be accelerating. So this is what the diagram looks like. We have, let me change. So this is what the diagram looks like. We have a friction force of 50 newtons acting against the box. We have 50 newtons that's being pushed with the box. And so it's moving at a constant velocity. The net force is zero because 50 newtons of force equals the 50 newtons of friction. That brings us to examples of things falling through the air. Let's say a sack falls from an airplane. At some point in its fall, it will stop accelerating and maintain a constant velocity because, and this is called terminal velocity. The net force is zero, the air resistance equals the weight. Normally, if there was no friction, if there was no air, and we saw this, I show this video in my class where they get all the air out of that one chamber at NASA, you can see that everything falls at the same rate when there is no air resistance, but something like a feather will fall slower because the air resistance will equal its weight because of the increased surface area and also lower inertia on that feather. So the net force is zero when it starts to do that. So our objectives were pretty fast and simple today to describe the effect of friction on a stationary and on a moving object. So don't forget your 5 questions.